Hello and welcome back. Today we're going to be checking out how decoders work. So the general basis of knowledge behind a decoder is you take a certain X number of inputs and then you run it through the decoder and then it spits out more outputs. And this can be helpful in large circuits where you need to toggle between, say you have a, sprinkler system. So you have a sprinkler here, a sprinkler here, sprinkler here, and one here. And then these all go back to a control room. And say you only want to turn on this one. Well, you take that one main pipe, but there's a controller in here. There's a main pipe coming in, but then there's a controller here that says only turn on one. Leave the rest of them off. So that way you can control just this sprinkler. In the same way, that's how a decoder works. For example, we're going to draw a quick explanation of how to do it, and pretty much this will summarize everything you need to know. We're going to draw a 2x4 decoder. So what the premise of this is that you have two inputs in A, B, and when these are fed into the decoder, it will spit out 4 outputs. Because what's the maximum binary number for, if you have 2 inputs, what's the truth table for a 2 input circuit? You have 0, 0, 0, 1, 1, 0, 1, 1, which is equivalent to 0, 1, 2, 3. So you have the binary of 4 separate options, 4 options. So what we're taking is the binary value and coming in, we're running it through the decoder, and then we're spitting it out as a 0. So this could be your 0 output, your 1 output, your 2 output, your 3 output, for a total of 4 outputs. Can't spell. Now, another way to look at it also is just the truth table itself. So say you have 0, 0, 0, 1, 1, 0, 1, 1. For a 2x4 table, for a 2x4, looks like this. You have your Q1, Q2, Q3, Q4. So it's going to look like this. You have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. So that's how it selects one of the values, basically. You can kind of just see it by looking at the actual truth table. And now we're going to get to the nitty-gritty. So here's how to make the actual circuit that is a decoder. 2x4 in this case. So you're going to have your A input and your B input, and then we're going to also want to invert one, so that's A not B, B not. Let's do it like that. And then you have your data lines that go out, and basically you're going to want 4 AND gates. If I'm not crazy, which I don't think I am. So you're going to have to tie first and the I'm having a brain fart here. Why am I having a brain fart here? I don't know. Oh, okay. Never mind. My mistake. Yeah, so you're going to want, so here you're going to have a B naught and an A naught. B naught, A naught. And then the next AND gate, you're going to want to have an A naught and a B. A naught, B. The next one, you're going to have a, let me think. You're going to want an A and a B naught. And then the last one, you're going to want an A and a B. So you can wire this up. I just have them drawn out. So this would all get wired up right here to that. So then the outputs are A, B, and then you have A prime B, and you have A, B prime, and A, B. And notice how none of these have the same output. That's how you get your 1, 2, 3, 4. Notice how they're logically all different. And then the feed coming in is what determines which one will be active and which one won't be active. In which case, only one will be active. One will be active at the right at once. Okay. One will be active at once. So there, it pretty much summarizes that you're just taking a binary value, binary and then you're converting that to outputs. And that's the general premise behind a decoder. It's more for, I'll show you in the next video, we're going to talk about how to make a 4x4 or a 2x2. We'll probably do a 4x4 memory module. And the decoders are actually super crucial in making a memory module. So if you like this video, sub, and the next video is going to cover memory modules, or just memory in general. Thanks for watching.